Hi everyone, my name is Sanjit, and in today's video we're going to be talking about AP Calc AB Unit 1 Video 3 on infinite limits in our organization Learnable. So basically in the last video we talked about how you can determine limits for most functions, but in this one we're going to be switching things up with infinite limits. So let's get started right away with the first problem. So let's find the limit as x approaches 0 from the negative direction. So this symbol right here, the negative symbol, just means that it's approaching x from the left side, and the positive symbol means that it's approaching left from the, it's approaching 0 from the right side. So that's all it is actually. So let's find the limit as x approaches 0 from the left side of 1 over x. So what's that going to equal? We can't just plug in 0 because it's not asking for the limit as x approaches 0. It's asking for the limit as x approaches 0 from the left side. So there's a difference there. So to find this, we actually have to create a table. X, y. So let's just try when x equals to 1. We have to get negative 1. We have to get closer and closer to 0 from the negative direction because everything left of 0 is negative. So when x is equal to negative 1, y is just going to be 1 over negative 1, which is just negative 1. When x is equal to negative 0.1, y is just going to be 1 over negative 0.1, which is just minus 10. One sec, let me move this up. And when x is equal to like a really small number, such as negative 0.00001, we're gonna get 3 zeros. We're gonna get negative 10,000. So what do we know about this? What can we see over here? We can see that as x gets closer and closer to 0, as x approaches 0 from the left side, y also approaches something. Y gets larger and larger in magnitude in the negative direction, which means that it's going to keep going higher and higher to negative infinity. So the limit for this problem would just equal negative infinity. Okay. There we go. Now let's just erase all of this. So this is just going to be equal to negative infinity. Now let's try and find the limit as x approaches 0 from the positive side, or the right side of 1 over x. So basically we're going to be drawing a table again. X, y, let's start with the 1. Y is just going to be 1 as well. When x is 0.1, y is going to be 10. When x is 0.0001, y is going to be 10,000. So it's the same thing. So as x gets closer and closer to 0 from the right side, y also approaches a number, or kind of. So y gets larger and larger, and as x gets closer and closer, y is going to keep getting larger and larger and becoming like it's going to approach infinity. So instead of negative infinity, from the right side approaches infinity. So let's just delete that of this. Now we're going to be trying to find the limit as x approaches 0 of 1 over x. Wait. There we go. Well, how do we find this? We can't just plug in 0. Well, we can plug in 0. That's how you would solve it. Since this would not exist, because 1 over 0 is just an asymptotic form, which is not, limit does not exist. But in reality, let's see how this is actually 0. Let's try to graph it this way. So what we already found the limits of a and b. So as x approaches 0 from the left side, like this one, y keeps getting larger and larger in the negative direction. So it's going to keep going to negative infinity. And since when x approaches 0 from the right side, y is going to keep getting larger and larger to positive infinity. So there's one rule we have to follow. So for a limit, let me just draw it somewhere else. There's no space over here. So we can just see that, wait, okay. For a limit, as x approaches a of f of x to exist, the limit as x approaches a from the negative direction of f of x should equal the limit as x approaches a from the positive direction of f of x. And in this case, in the graph, we can see that when it's approaching x from the left side, it's going to negative infinity, and when it's approaching x on the right side, it's going to positive infinity. And those are not the same number, which means that the limit does not exist. That's how you find it graphically. So we're just going to erase all this. Equals does not exist. Limit as x approaches 0 of 1 over x does not exist. So now let's go into this problem right here. These few problems. Let me center it. Okay, there we go. Now we have to find the limit as x approaches 2 from the left side of f of x. So f of x is this equation right here, and we're trying to find the limit. Let's find it graphically for today. So the limit as x approaches 2 from the negative direction. So what will that be? So let's first identify where x equals 2 is. So what is x equals 2 right here? It's an asymptote. Asymptote basically means that no value of the function can cross that line or even touch that line. So all we know is that as x, now we have to look at the limit as x approaches 2 from the left side, right? So what's happening to the function over here? It's going down and down. It's getting larger and larger in the negative direction, and it's never going to cross that x equals 2. It's going to keep going to infinity, but in the negative direction. So this is just going to be negative infinity. And for the as x approaches 2 from the positive direction, this is going to get larger and larger in the positive direction, which is just going to be infinity. So what's going to happen as g of x of what's going to happen to the limit of f of g of x as x approaches -1 from the left side? So -1, where's -1? It's right here. This is an asymptote, just like f of x. Tote. Okay, my handwriting's kind of bad, but yeah. Anyways, from the left side, what's happening to the graph? It's going down. It's going to go to negative infinity. From the right side, it's going up, and it's never going to cross this line that's x equals -1. So that's also going to go to infinity, but in the positive direction. So okay, now we're gonna find the limit. We're gonna switch things up and find the limit as x approaches infinity. So how would we do this exactly? It's basically the same concept. You just have to trace where the function takes you as you approach that certain number. In this case, infinity is not a number. It's just you just have to look as x gets larger and larger, what happens to y. So as x gets larger and larger, y actually goes to infinity as well, because we're looking at f of x, sorry. As x gets larger and larger, you see this horizontal asymptote right here, which is at y equals 2. This function is going to get as close to that horizontal asymptote, but it's not going to touch it because it's an asymptote. So this function will approach y equals 2 when x approaches infinity. So this answer is going to be 2. For as x approaches negative infinity, which means from this side, same thing's going to happen here. It's never going to touch that y equals 2, so it's going to keep going that way, but get as close to it as possible. So this is also going to be 2. So now let's find the limit of g of x as x approaches infinity. So what's going to happen here? This is going to go. This is going to increase forever and just become infinity, while this value right here is just going to go down forever and become negative infinity. So what did we learn today? So today we talked about finding limits as x approaches a certain value of a function that has either an asymptote. As x approaches an asymptote, we talked about what happens to the function, and there are many things that can happen. And we also talked about finding the limit as x approaches infinity. Let me move that screen up. Yeah. And negative infinity. We also talked about the meaning of plus and minus. So yeah. In the next video, which is I think unit, which is gonna be, let me check. It's one-sided limits. So we're gonna be talking about one-sided limits, and it's actually gonna be really fun. Okay, have a good day.